Hi guys, good evening.
Good evening. We can start the session in 2 minutes. We'll just wait if someone else also will join. Okay, I guess we can start. Melvin,
Yeah,
can you go first?
yep, sure. So in a lot of previous paper, we had like generally read about the closed parking lot, census for the closed parking lot, but this one is a little bit different, and it was on the open parking lots. So the two main issues was the expenditure, the cost of purchasing and maintaining the census, and the compatibility, like due to varied environmental conditions and lighting changes. So the core problem was that majority of the parking spots are either easier to be constructed in an open lot than an underground or a closed spot, because the parking spots that are being closed are generally for constructed by a uh, group of companies, like let's say either in malls or near airports, but majority of the people who do park are generally parked in the open spots. So this will be addressing that. So the sensors were actually classified like on the basis of are they suitable with the environment, the function, and the expenses. So the sensors that were not suitable due to environmental reasons were infrared sensor and ultrasonic sensor, because infrared sensor is susceptible to rain and snow. So this will lead to inaccuracies, and ultrasonic sensor, which uses sound waves to detect object, will also not be suitable due to its sensitivity to rain and snow. And unsuitability due to function was the cause of not using inductive loop detectors. These are installed underground, often near entrance or exits to count vehicles. They are not suitable for open lots as they cannot provide the status of individual parking lots. And next is the RFID. This technology was used for to authorize vehicle. This is also not suitable as it doesn't also give us specific information on a parking lot. And due to cost, the magnetometer and the microwave radar were also not suitable, because the magnetometer had to be installed in every parking lot, and which thus increase the cost. And the microwave radio, this detected the stationary vehicles like magnetometer. They are suitable but too expensive for a large scale open lots. So the technologies that are cost effective for this is the GPS and the vantage system. GPS is the global positioning system, but it the issue with this was mm, the time delay that took to update the system, and the defect. It cannot properly detect the occupancies due to the time delay. The VANET system was a vehicular ad HOC network. This uses communication between the onboard sensor and the roadside infrastructure, which keeps communicating, and through this, when they interact with each other, it can confirm that this parking spot has been occupied. But the downside for this method is that it is very expensive, as both the onboard unit and the roadside unit have to be installed, and the number of roadside units that needs to be installed is way more. And it cannot work with all the vehicles as the onboard unit needs to be installed, and that will also add additional costs. And then uh, the next method was the predictive analysis. This can be used to predict the occupancy of a particular spot during a particular period of time in a day. This is low cost, but it cannot provide us the real occupancy information. The recommended method that was the method that was recommended in the paper was the mission vision, in which cameras can be used to monitor a parking lot, and through the machine learning language model, it can be used to predict whether the spot is occupied or not. So, and the challenges of this are shadows and low lighting conditions, which can affect the range of the camera and can thus give us false report. And the other one was the neural networks. This took advantage of the CNN, the convolution neural networks. It is a type of deep learning, and it is very effective for image analysis and thus can help our camera in identifying the spots when there is a confusion. And this is all, the cost of this is also minimal, so it is also very scalable. So it also goes into the parking smart parking apps that are which are mostly for closed parking lots. So the most parking apps use the underground sensors to show real time occupancy and show the reservation. Some apps like Parkopedia use predictive analysis, which are not real time. Other models like crowdsourcing are not reliable and are prone to human error due to the lack of constant update and reliable updates. Crucially, the review found out application that provided real-time parking occupancy information for open parking lots. So, in the conclusion, the author proposed that the mission vision and the convolution CNN are the most feasible and financially viable solution for open parking lots, as these are low cost and can be trained to be resistant to environmental condition of an open lot. And but there were also challenges mentioned for these two methods. The first is the privacy, as the use of surveillance camera in public area is restricted by law in some countries like Sweden. And the paper also suggested an alternative for this, which is a thermal camera, but it cannot be thermal camera because it can not specifically identify a specific person, so it can just detect whether it's a person or a car. And other one was the real time navigation, because since reservation is not possible in open lots, a space that is vacant when the driver is routed to it might be taken by another vehicle before they arrive. So this also needs this the system also needs to update it constantly. So thus, yeah, that was my analysis on the paper. And the paper was also mentioning like further research on the deep learning and the multi-agent system which are being developed, like more research can be done on these topics for open parking lots.
Okay, thank you, Melvin.
Thank you.
Um, so now, Syed,
Yeah, good evening, everyone.
yeah,
Yeah,
good evening,
so
Syed.
let's head towards the smart parking system and technologies for open air lots. So, as we discussed in our previous sessions, also for the closed parking lots, we have figured out one major problem is that the ultrasonic sensors are not reliable because they are low cost and they are very like sensitive towards the environmental conditions. So the main what we say issue is that for the parking lot we have to like the 30 to 40% drivers look for spaces because they can't find the perfect space. The consequences are the congestion, environmental pollution, driver frustrations, and leads to accident. And lack of guidance are also there. So what the paper suggests, they suggest some mm, methods and techniques to tackle these things. Like the classic one is the public transport, use of public transport. and electric vehicle slow replacement rate, driverless cars for future technology which use GPS and senses V2V. But this will take decades because right now the most 99% of the population is using petrol or diesel, so we cannot just simply switch to another modes of way transport. So there the parking system will come in the picture. So the smart parking have, like the research paper had discussed many of the method. So there are some ultrasonic sensors which are not good because they are not reliable for harsh environments. And there are magnetometer and microwave radar, which is good, but they are too expensive. For that, we have to make an underground repair and service center also, which is not like feasible to for our economy. And the paper is also discussed about like CNN, which is a very good idea because the CNN we don't have to teach him that how this is a car look, how it should be. We can just give some thousands images and it can learn, okay, that this is a car and this is this, so we can use this. So the on the machine vision camera, what we can do, so like Melvin addressed that the privacy issue, we can guarantee end-to-end encryption. And if a government interfere, we can work according to the government policies, what the country have their privacy policy. Then the next thing I see that the paper is ask about the thermal cameras, but the main like what we say pawn of the thermal cameras is like we cannot. It will in the rainy season it will mismeasure the temperature, so it's not reliable in the harsh temperature like heavy rainfall or snowfall in some countries, so we cannot rely on it. And I think about several methods also like using IR sensor and NFC, but they are not feasible to the economy. So the last what which I have think about is like using FASTag on the exit and the entry of the lot, so that we have a count of cars. Like suppose the lot have capacity of 100 cars and there are 50 cars in the lot, so the FASTag, the entry and exit will count the how many cars are in the lot currently, so we can predict this like this in harsh conditions, like if we heavy raining and heavy snowfall, because FASTag will work in every condition and it's reliable also. And second, we can combine it with the machine vision camera. And one thing we can do that, like we can on the screen of the machine vision camera, just after the camera screen, we can put some hydrophobic coating so that in the heavy rainfall, the raindrop does not stay on the camera screen, so we have a better vision. For the snowfall side, we can make some slides on it, so the snow just go away from the slide. With the help of CNN, we will have some clear image of the lots, like how many are there and how many are not there. And if someone is exiting, we will get the information with the help of FASTag. So we can use this one because I just found this thing which is working perfectly fine. We have to just set up two FASTag machines, one on the exit and one on the entry. And everyone right now have FASTag in their car, so we don't want to install something else. This is my study.
Yeah. So, but actually, the FASTag technology is always already implemented in the malls, right?
They are on the toes, I think.
No, no, no. Even in the malls, at least in South India, like many malls now charge the parking fee based on FASTag. They automatically detect the money.
But we are not detecting any money. We are just counting how many are there because parking lots, open lots are free.
Oh, okay. So, like, then why are you counting the vehicle?
Suppose if in harsh conditions or in some conditions our cameras are not able to see any car in the lots, so that we have some estimated that okay, there is 45 cars in the lots, so more can be entered.
Okay, okay, got it. Yeah. Okay. So thank you, Syed. So Melvin and Syed, so you two have been like active from like almost the only ones active. So I have so right now you're planning to write a review research paper. So I would like you both to like just uh, um, brief up yourselves about the latest technology in smart parking so that we can soon start writing a review paper. I hope you both know, right? Like what's a review paper?
Can you tell us?
Okay, so research review paper is basically like instead of writing about your research, you can just write about the research performed by other people so that anyone who is going to start a research can just see your paper and then they can immediately start. They don't have to like read others' papers so deep dive and all.
It's like collecting the data and summarize it in the short, right?
Exactly. So like, can you just collect the info and like
On the smart parking, right?
exactly like latest technology like nowadays what they're using like using cloud for the smart parking or any other um yeah so basically the latest technology involved in smart parking.
Yeah, fine.
Okay, Melvin.
Okay, yeah.
Okay, yeah. So I guess that's it for this weekend. Okay guys, and see you next weekend. Thank you, bye.
Okay, bye.
Yeah, thank you.